What's up, scholars? Welcome back. Today we're going to talk about arc length and sector area. You ready for it? Oh yeah, I'm ready for it. So what do you mean arc length and sector area? We talked about the measure of an arc in degrees before, but how long that arc is depends on how big the circle is, right? If this is a 60-degree angle, that could be a 60-degree arc, but it would be a much longer arc if we had a really long radius, or it would be a very tiny arc if we had a tiny radius. So the two equations we're looking for, first one for arc length is going to be 2 pi r. What is 2 pi r? Oh, that's circumference. That's the circumference. Circumference. That's the circumference times however many degrees that angle is, which is the same as the degrees of the arc, right? That theta, that degrees for the arc measure, divided by 360. So that's how much of the circle that arc takes up times the circumference of the circle will tell us how long it takes to get from Q to P. And then the sector area, what's a sector? Well, it's a chunk of a circle. So the sector area is how much space this whole thing takes up. So for that one, we're talking about pi r squared. What's pi r squared again? Well, that's the area of a circle. It's the circle area. So it's the circle area times how much of the arc this arc takes up in a circle. So it's pi r squared times the measure of the arc divided by 360 degrees. All right, Alex, what you got for us? All right, Alex says the circle below has a center at K. So for example here, our circle below has a center at K. That's a crazy looking center. And its radius is 7 yards. So we've got K, then we've got this radius that's 7 yards on both sides. Then we've got this point L and this point M. And it says, find the length of the major arc, LM, M's up here, N. All right. So if this central angle here is 60 degrees, that means the measure of this arc here in degrees is 60 degrees, which means the arc that we're going to be talking about, LMN, is 360 minus 60. 360 minus 60 is 300 degrees. So now we're finding the measure of the, the length of the major arc in terms of pi. Oh my gosh, that's so wonderful. There's no rounding that's going to happen. Que fabuloso. All right, arc length. So arc length is 2 pi r times our theta divided by 360. The theta, again, is the measure that we're looking for here. LMN is 360 degrees. So the measure of the major arc, the arc length, the major arc. This time we will not put the little m in front that indicates measure since we're talking about the length here. So we'll say LNM. The length of LMN is 2 pi times the radius, which is 7 times theta over 360. Theta over 360 is 300 over 360. And then we get out our handy dandy calculator and we do 2. We're going to leave pi in our answer, so don't do anything with that. 2 times 7 times 300 divided by 360 is 11.6 repeating pi yards. 11.6 repeating, we could put into a fraction form because that's really 11 2/3 pi yards, which could also be 11 times 3 plus 2, which would be 35 over 3 pi yards. Awesome. Let's do another one. Let's get some more paper. All right, next example. We got a circle. We got a center at C. We have point D here and a point E here and a point over here, F. Wow, that circle got crazy on me. There we go. Says the radius is 4 meters. 4 meters. It says the central angle DCE is 130 degrees. So that means we know that the arc on the outside, that minor arc, is 130 degrees. Find the length of the major arc DFE. DFE is going to be 360 minus 130, so that's going to be 230 degrees. So again, we're finding our arc length for DFE. That's equal to 2 pi r times theta divided by 360. So that's 2 pi times our radius, which is 4, times our degrees, which is 230 divided by 360. It says leave our answer with pi and include correct units. Can do. So we'll leave pi alone. We'll do 2 times 4 times 230 divided by 360. And we get 5.1 repeating meters, which is 5 1/9 meters, which is 9 times 5 plus 1. 9 times 5 is 45 plus 1 is 46/9 meters. Cool. Very good. All right, now let's find some sector areas. In the circle below, we've got a circle centered at O. It's got a radius that is 8 feet. 8 feet. And that means this guy over here is also 8 feet. The measure of angle AOB, this one right here, AOB is 80 degrees, which means that the arc A to B is also 80 degrees, which means this arc on the outside, that's a D there, BDA is 360 minus 80, which is 280 degrees. It says find the area of the shaded region and the length of arc ADB. All right, since we've been doing arc length, let's just start with arc length. Arc length is 2 pi r times theta divided by 360. We're looking for the arc length of this big guy on the outside, ADB. So 2 times pi times our radius, which is 8 feet, times our degrees, which is 280/360. It says leave our answers in terms of pi and include pi in our units. I just realized I didn't leave pi in the last one. There should have been a pi there. And I think maybe there should have been a pi in the previous one. Oh, wait, there was. Okay, cool. Perfect. Pi's there. Pi's there. Pi's there. Pi's very important. Anywho, let's multiply our numbers. 2 times 8 times 280 divided by 360. 12.4 repeating, 12.4 repeating pi. Our units are feet, our arc length in feet. So this is 12 4/9 pi feet, which is 12 times 9 plus 4, which is 112/9 pi feet. That is our arc length. Now our sector area. Sector area was the area of the whole circle, which was pi r squared, times that same theta over 360. So now we've got pi times our radius, which is 8 squared, times 280/360. What do we need to do first? Our squared. That's what the order of operations says. 8 squared is 64. 64 times 280 divided by 360 is 49.7 repeating pi feet squared, because we're in area. 49.7 repeating is 49 7/9 pi feet squared, which would be 49 times 7 divided, 49 times 9 plus, oh my gosh, 49 times 9 plus 7 equals 448 over 9 pi feet squared. Cool, cool, cool beans. Give me another one. This is our last example. All right, the circle below, boom, has a center at O. It's got this A over here, got this B over here, got another point over here, D, and it says the radius is 6 feet, 6 feet. It says the measure of AOB is 104 degrees, so we know this guy is 104 degrees. So we know this guy is 360 minus 104. 360 minus 104 is 256 degrees on the outside. Find the area of the shaded region. Oh, so I went a little hard there. We didn't even need to know that because we're just looking at the small one. So arc length was 2 pi r times theta over 360. It's going to be 2 times pi times our radius, which is 6 over theta. That we're looking for arc AB. So we just want this theta, this 104. 104 over 360 equals, yes, we just leave pi in our answer again. 2 times pi times 104 divided by 360. All right. Is that correct? Let me just make sure. 2 times 6 times 104. 2 times 6 times 104 divided by 360. Yes, it is. 3.46. Repeating. Our units are feet. Wonderful, wonderful, wonderful. And our sector area is going to be pi r squared times theta over 360. So that's going to be pi times our radius, which is 6 squared, times 104 over 360, because we're looking for how big is that chunk of the circle. So we'll do 6 squared, which is 36, times 104 divided by 360 is 10.4. Wonderful. So our sector area here is 10.4. I forgot pi again up here. Akin, get it together. So we've got 10.4 pi feet squared. Wunderbar. All right, what we talked about? We talked about arc length and sector area. Arc length is how long that arc actually is, not what degrees it is, not the chunk of the circle it is, but literally how long it would take you to get from point Q to point P. And we use the formula 2 pi r times theta over 360. That 2 pi r is the circumference. So we're really taking the chunk of the circle, like the percent of the circle, times the circumference to find that. And our sector area is how much space that chunk of circle takes up. So we did the area of the whole circle times that chunk of the circle, that percent of the circle. So we did pi r squared times theta over 360. Wonderful. Ms. Atkin, as always, it's been a pleasure. Thank you so much for being here. I really appreciate it. Yeah, you're a great host. You know, so good, such good fashion sense. I love your coat, by the way. Have I said that before? It's so nice. Anyway, we love you, scholars. We'll see you next time. Keep on that hustle. You're doing great. You're almost done.